Hi everyone, we're back with our IM2 book this time, and we are going to start off on chapter 1 and chapter 2, which is all about basically basic trigonometry and also angle relationships and then shape relationships. So starting off with chapter 1, we have a unit 1.1 on classifying shapes, which is basically recognizing the patterns between shapes and knowing what to call them. So we're going to start off with regular polygons. And remember, a polygon is just a shape with multiple sides. Poly means multiple. So we have, for example, these drawings aren't going to be perfect. like this. And then if I said these two had equal length pairs, then I would say this was a rectangle. And then if it was all equal sides, then I would call this a square. Those are pretty basic. There are other things, like I said, the regular polygons is any shape. So like a pentagram, for example, that has both equal sides and equal angles. So that's what a regular shape is. Because this may be a regular pentagram, but there may be another shape, just scribbling here, but there may be another shape that also has 5 sides, and is a polygon, so it doesn't have any rounded sides, and is still considered a pentagram. Okay, and then kind of leading into what Oleks is going to talk about later, we have to know how to classify triangles. So there are so in terms of angles, there are 3. There is a right triangle. There is a obtuse triangle, which is one angle is greater than 90 degrees, and there's an acute angle, where a acute triangle, where all the angles of the triangle are less than 90 degrees. In terms of sides, there are three classifications. One is the equilateral triangle, which means all sides are the same, and therefore all angles are the same, but we'll get to that later. And then there is the isosceles triangle, where 2 sides are the same. And then finally, there's a scalene triangle where none of the sides are the same. Oh, this kind of looks like one side is the same. Where, let's just say that's the scalene triangle, where none of these sides are equal to each other. Okay, and that's basically the introduction to classifying shapes. And then angle relationships. So when you come across this is just for like textbook relation sake, but there are going to be shapes sometimes where you notice these line patterns. And these line patterns often, if not always, show up in some form of 2 parallel lines. So we'll just say these are parallel, and a transversal. A transversal is basically this, I'll color it red, this red line here that goes across. So a line, it goes in one direction, or one line and then opposite directions, and it goes across these 2 parallel lines. And then there are many different angle relationships. We're going to look at the main one. So first are supplementary angles. Which are angles that add up to 180. So 180, as we will find out, is just the angle of an entire line, a straight line. So what angles in this parallel line transversal are supplementary? We would say this angle, we couldn't call it A, and we call this angle B. So angle A, and angle B are supplementary. The other angle relationship in this is complementary. It's not in this like transversal graph, but supplementary is basically the same thing, except angles add up to, complementary angles add up to, so angle A plus angle B would equal 90 degrees. Okay. Now we're going to talk about, okay, so there are in terms of this transversal graph, there are two special types of angles that we need to pay attention to, which are alternate interior angles and same side interior angles, and then interior can be switched out with exterior and whatnot. Okay, so 1 or 3, alternate interior. This would be something like, so interior, what does interior mean? Interior means inside. So just think, in this system of lines, which angles are inside? The ones on this side, not these. The ones I circled in red are the outside exterior angles. The ones on the inside, which are blue, are the interior angles. And then, so I'm just gonna go through this really quick. These, A and B, what are blue right now, are alternate interior angles. They are on opposite sides, but they are still on the inside. And these add up to 180 degrees, so they are supplementary. And then interior or same side interior angles, one here, one here. Remember, same side, and they're on the inside. And these also add up to 180 degrees. So this is A, this is B, A and B add up to 180 degrees. Now let's think alternate exterior angles. This would be, remember, alternate, opposite sides. Exterior means outside. So it would be one here, one here. And then these angles, wait, I think I messed up before. I think alternate interior angles don't add up to each other, they're equal. It's fine, it's fine. Okay. So these are alternate exterior angles and they are congruent. So angle A equals angle B. Or you can say the congruent symbol. And then let's look at same side exterior. So this is the same thing as before, on the outside and on the same side. So this would be here and here. And angle A and angle B, they are supplementary. So they add up to 180 degrees. And that is it for angles.
Hey everyone, I'm Oleks, and let's talk a bit about triangle congruency. So this is different from triangle similarity. Two triangles that are congruent are similar triangles, but two similar triangles aren't necessarily congruent. A good way to think about it is if a triangle is congruent to another triangle, it means that you can move it and rotate it somehow, and it can map exactly on the other triangle. So basically, they're pretty much equal. There are, well, here there are five ways we can tell that two triangles are congruent. The first way is SSS, and this stands for side-side-side congruency. This means that if all three sides are equal, so we have three pairs of equal sides on each triangle, this means that the two triangles are congruent. The other way is ASA, which stands for angle side angle, in that order specifically. Basically, if you have two pairs of congruent angles, and then between them a pair of congruent sides, that means the triangles are congruent. And by the way we denote congruency here is if there's a mark that is the same on both of the triangles. For example, here we see like this little two lines mark right here and right here. This means that those two things are the same. So here you can see that both of the lines have a singular mark on them. That means that they're the same. All right, so the next way we have is right here, and that is the AAS. And this stands for angle side, obviously. Also located in the triangle in that order. So if you have two pairs of congruent angles and then a side after them, then you know the triangle must be the two triangles must be congruent. Next we have SAS. So this is similar to ASA, except you have two pairs of sides that are equal, and between them you have an angle that is equal, and that also means congruent. And then finally, this is HL congruency, and this is relating to right triangles, and this is pretty much the I mean the this is very similar to the SAS congruency. However, notice that the angle is not necessarily, so the angle that is the same, which is the 90-degree angle, isn't necessarily between the two sides, right? So this stands for hypotenuse and then leg, I think. And the legs are the same, the hypotenuse are the same, and they're both right triangles, and you know that they're congruent. Though in general, if you have like a side angle congruency, that doesn't necessarily mean that the two triangles are congruent. Only if the two triangles are right, then it is. So now let's look at some examples right here. So let's start with example A and then see if the two triangles are congruent. So in this case, we see two pairs of sides that are congruent. So we have a side here and then a side here, and then another pair, so right here and right there. And then an angle between them that is congruent. So as a result, we can say that this is SAS congruency. Now let's look at B. So we see that there's three pairs of sides that are equal. So we can just say right away that this is SSS congruency. Now here we have two angles that are the same and then a side after them. So this is AAS. So this is also congruent. And be careful not to confuse AAS with SSA, because SSA does not necessarily mean congruent, but in this case it's two angles, so it is. Here we have similar to the first one, except it's the side nested between the two angles. So we see that these two angles are the same, and also these two angles are the same. We can tell because the marking is the same, right? And then same thing with the sides. So we can say that this is ASA, angle side angle. Now let's look at E. So E, we have the last type of congruency, right? We have two right triangles, and we have the legs that are equal and the hypotenuse that are equal. So we can just say that they're congruent. So let's just do HL. And then finally, we have these two, which is the same as example D. We have two pairs of angles that are equal, and then the sides. So we can also say this is ASA. All right, but when you get these type of problems, oftentimes it's not just two triangles that are separate. Sometimes they're a bit more tricky. So if we go down, so if we go down, we see a problem right here. That's a bit harder to tell because we have an angle that is the same, and then we have a pair of sides that we know is the same because of the marking. But are these triangles congruent? And the key thing here to realize is that for these two triangles, this side is also the same. So we can just do something like this. So we have these two sides that are the same because it's a shared side and must be the same for both of them. We have a pair of sides that are the same here, and we have an angle between those two sides that is the same. So it's important the angle is between the two sides. And as a result, we can say that this has a side angle side congruency. So this means the two triangles are congruent. So now let's go to more of these examples on the right. So right away, here we can notice that the markings are a little confusing. So let's try to work through this. So we know that this angle is equal to that angle. So these two angles are equal. Now, we know these two angles are also equal. Now, on this side, we have two markings. On this side, we have three markings. We can't really claim that the two sides are the same because the markings are different. However, there is a side right here that is the same to this side, right? And that side is between the two angles, which is one of our types of congruencies. And this is the ASA congruency. So we can say, yes, these two triangles are congruent. Now let's go to the next example. Again, we have some extra markings. So let's see which ones we know are the same. So we know that this angle is the same as this angle right here. And we have two pairs of congruent sides around that angle. So right here, and then also right here and right here. And as a result, we can say that this is SAS congruency. All right, and now for our final example, we have this triangle where we know that there's two pairs of sides that are equal, right? This pair and then this pair. We're not really sure about the angles. It looks like it's a right triangle, but we can't claim that it's a right triangle because there's no like this kind of marking, so it might not be a right triangle. But what we can claim is we can say that this third side must also be equal because it's shared. So if you imagine if we like sort of split this triangle into two triangles we're trying to compare, we can see that the third side must also be equal. So as a result, we have SSS congruency. And that is pretty much all I have on triangle congruency.